Okay, so because we made ice cream last class, we have a lot of notes to take, so just bear with me and we'll get through them, okay? Weather patterns. This is a review. Remember we talked about the air masses having the properties of the earth where it formed? You can have dry forming over land, moist forming over water, warm and then cold. And because of that, we had all of these air masses coming in, and right here in the center, that's where we had Tornado Alley. And we're going to talk about tornadoes today and why these air masses, the very cold and dry, the very warm and moist, warm and dry, cold and moist, equals a medium-sized cup, and all that moisture flows out in the spring. Okay? We talked about high pressure, indicating fair weather because it's pushing down on the earth. Air is not allowed to rise, cool, and condense into clouds. Low pressure isn't pushing down on the earth, so the air can flow upward, rise, cool, condense, and we have clouds and rain. We also talked about the highs feeding the lows, and everything in nature wants to go from a high to a low pressure. Okay? So this is where we stop. It's the front. It's the boundary between two air masses that have different characteristics. It could be density, moisture, temperatures. So when air mass 1 meets air mass 2, there's a collision and there's usually a conflict. If you have a warm front, the warm air is less dense. We know that more dense stuff sinks, less dense stuff rises. So it gently rises over that cold, moist air. So in a warm front, you're going to get light rain. You're going to get those high, wispy cirrus clouds. And we'll do the symbols together when we go over it. A cold front is opposite. A cold front, the cold air moves in and it's very much more dense. It's going to shove that warm air up and out of the way, and it's going to make violent storms. Okay? It's going to be very stormy, very thunderstormy. All that warm air is going to have to go up very quickly. Clouds are going to be nimbus filled with rain. And again, we'll go over that symbol when we talk about it together. An occluded front. OCC. Okay, so if you see those two C's, you know it's two cold, dense air masses coming together. Unfortunately, there's usually a warm air mass in the middle. So it's going to be shoved up very quickly, very stormy, and we'll go over that symbol when we get to it. The last one is a stationary front. This is when the pressures cause a warm or a cold air mass to stop moving. So it's really not going anywhere. It's going to produce steady rain over a long period of time. It's just kind of stalled out, stationary. So now we're moving on to meteorology notes number 3, and this is severe weather. Thunderstorms, heavy rain, lightning, thunder. These are going to occur at fronts, usually cold fronts and occluded fronts, and in very warm, moist air masses. So we can have thunderstorms in the middle of the summer on a really hot summer day, even if there's no front. Warm air rises, and then you're going to get that cumulonimbus cloud. You're going to have strong winds associated because of the heavy rains that are falling through the clouds. Lightning is a form of plasma. Now you know, we only said that plasma was found in the sun. Plasma is the most abundant form of matter in the universe because all suns, all stars are made up of plasma. But it's the least amount found on the earth because it's only in lightning. So how do you form lightning? It's created when warm air lifted and cooled. Cool air is sinking in a tall cloud, making those molecules build up of opposite charges. So you get positives, you get negatives, and then on the ground you're going to attract the different charges. So you've got negatives here that are going to be attracted to the positives. The positives out here are going to attract the negatives. And when you have the two meet, then you're going to get a flash of light known as lightning. Okay, oppositely charged molecules meet. So you have your negatives in the cloud meeting the positives on the ground. Now, lightning can travel from cloud to cloud, cloud to ground, or within a cloud. Within a cloud is called heat lightning. At any point, that lightning can change and go to the ground or go to another cloud, okay? From the cloud to the ground, you're going to have a buildup of charges in both the cloud and on the ground. The charge leaves the cloud and is met in the middle by the charge leaving the ground. This is actually what we call a leader, and it's just a column of air which the free lightning can pass through. Lightning tends to follow the path of least resistance. So if the column of air is broken, if that leader stroke is broken, then it starts to branch. So here's our normal leader, okay? And then something happened here, whether it was a shift in wind or an air pressure difference, but right there it broke off, and you can see that the lightning is going to branch out down here and travel where it's least resisted. The bright flash of light that we see is actually called a return stroke, and it actually is what happens after the leader. It comes down, it hits whatever the opposite charge is, and then it flashes back. But light is so fast, remember it's 300,000 kilometers a second, so it's so fast our eyes can't register which way it's going. Thunder. Thunder is a result of lightning, so it should be lightning thunder, not thunder and lightning, okay? Thunder happens because you're going to heat the air as the lightning passes through it, and we know that hot air expands. We saw that in the liquid nitrogen ice cream in the balloon, and when it runs into that cooler air, that's when you get the boom. The speed of light is faster than the speed of sound, so we see the lightning before we hear the thunder. Kind of like in this picture, you would see the fireworks before you hear the thunder after. You can always tell the distance that a storm is away from you. If you see the lightning, you count the seconds until you hear the thunder, and then you're going to divide by 5. So if you see the lightning and you go 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, boom, you know that storm is 1 mile away. Lightning can travel up to 10 miles away from the storm. Never stand in an area under a tree. The charges tend to go to the highest point. So we often see lightning rods on tall buildings, on tall bridges, and that'll attract the lightning to keep people safe underneath. All right, we made it through that notes. Now we're going to do section 4. Tornadoes and hurricanes. So tornadoes are violently whirling winds that move in a very narrow path. And remember we said that this is going to happen because of all those air masses that meet in the middle of the United States in that very flat land. So it's going to form over land. It usually moves from the southwest to the northeast, and it's going to form in very severe thunderstorms, very tall cumulonimbus clouds. The formation, we have what's called a wind shear, and the wind is going to blow in different directions and at different speeds. It also is at different heights. And this is going to produce a rotation of the wind inside the thunderstorm. So nothing is even showing yet. This is all within the cloud. If you have a really strong updraft or downdraft, this can turn what we call the vortex, that rotation, and it can actually pop that tornado out of the cloud. So there's what a tornado looks like. The dust, the color down here, is going to be because of the debris that it picks up. So this is the spinning vortex. Again, it's going to be colored due to the debris it picks up. You can have pink ones or dirt ones. That's going to be over here. Okay, you can see that color is very different from this color. And if it's a water spout, it's going to be clear because it's going to be picking up water. There's no debris in it. Tornadoes can reach up to 500 kilometers an hour, really, really fast winds. They can range in size from about a mile to many meters across. And that tornado alley that we talked about includes Texas, Oklahoma, and Kansas. Very, very flat states, so those winds can pick up some speed. They do have very, very unpredictable paths. You can't really track a tornado or how long it's going to stay on the ground. We have what's called the Fujita scale. And Mr. Fujita was a scientist, and he actually came to the United States because we have so many tornadoes here than in other countries. The F scale is 0. Branches are just snapped or rotten trees fall down. We've had 40 at this time when this print was printed in Virginia. F1s, windows start to be broken and trees are snapped, not just fall down. We had 90 of these in Virginia. F2, roofs are torn off, trailers are demolished. At this time we had 56. F3s, roofs and walls are torn off houses. Well-constructed houses can be collapsed. We had 22 of these in the state of Virginia. This is usually the most damaging tornadoes because we have so many hills and mountains that it kind of chops up those winds. F4, 200 mile-an-hour winds. Houses are going to be leveled, which means that there is nothing